In the previous section, we have implemented our UI and we have implemented a way for our player to restart the game using this button. Great! Now what we can do in this section is implement some kind of gameplay so we can spawn our enemies around our map so that they attack us constantly. So for now, let's first select one of our charts. Let's make sure that no overrides, no important overrides are done here. We can see that there is some change in Shadowcaster. We can delete all those 3 enemies and for one, choose the override and apply just for safety, and let's delete it as well. Now, what I would like to do is choose the player from the hierarchy, choose the move tool in the scene view, and let's move the player to the center of our map. Now, what we would like to do is we would like to create a spawning script that will spawn our enemies either in 4 corners or in different positions. We are going to make sure that we can set those positions, and then algorithm will choose randomly where the enemy should be spawned. So what we are going to do is we are going to create a new game object in the hierarchy, right click, create new game object. Let's reset its position, it will be important, so let's click those 3 dots and reset it, and let's call it enemy spawner. Okay, and what we are going to do is we are going to create a separate script that will drive this enemy spawner game object. So let's go to the project section, let's select _scripts folder, let's select our enemies, and I think here we are going to create our spawner. So right click, create C# script, and let's call it enemy spawner. Let's open this script up in Visual Studio. Great. Now, again, let's delete the update and start methods. We will create them as we need them. So what we will want to have here is a private game object. Let's call it enemy prefab. Of course, you can create a list of enemy prefabs. We are going to add a serialized field attribute to it. Another field that we need to have is a private list of game objects, and this will be the list of game objects or other spawn points that we will create. So let's call it spawn points. Again, let's add to it serialized field attribute so we can set it through the inspector. Next, we are going to create a private int count, and this will be the count of the enemies that we want to spawn. Let's set it to be 20 by default, and we are going to create private float, and this will be min time or min delay. Let's set it to be 0.8f, and max delay it will be equal to 1.5f, and those will be the delays between the spawning of enemies. Let's add serialized field attribute to both of those, so the count and to the delays. Great, so those will be the parameters for our spawner to spawn our enemies. We will need to have some kind of coroutine that will allow us to spawn our enemies. So let's start with that. We are going to create I enumerator. Let's call it spawn coroutine. Okay. And in here, we will want to make sure that we can spawn our enemies. So we are going to spawn our enemies only if we are not exceeding the count. So let's type while, and this will be our while loop. And while count is greater than 0, what we are going to do is first of all reduce the count, so count minus minus. Next, of course, this will be visible in the inspector, so you might want to have a separate private value for it, but we are going to use this count so that we can see how many enemies are yet to appear. We will need to have a spawn points attached to this list, so we are going to create some game objects that will represent the spawn points, and we will need to randomize where we are spawning our enemy. So we are going to first create var random index, and what we are going to do is we are going to set it to be random dot range, and we are going to pass here from 0 to spawn points dot count. So we may want to make sure that our spawn points never is empty, because if it is, we are going to access the index 0, and this will make our code throw an error. Next, when we have our random index from our spawn point, we are going to make sure that we have some offset, since if we spawn two enemies on the same position, then they will start colliding, and this might be an issue for us. So let's type var random offset equals, and let's set it to be equal random dot inside unit circle. Great. Now what we can do is we can call our var spawn point equals, we are going to call our spawn points list with the random index. So this will be the position, so dot position, transform dot position. So this is the position of our spawn point, and we are going to add to it random offset. Okay, and we cannot add vector 3 and vector 2. We are going to upcast vector 2 to vector 3. Okay, now we should be good to go. We have our random position, our spawn point. So what we can do is call a method spawn enemy, and we are going to pass our spawn point. We do not have this method, so Alt Enter and generate it. Great. And now last thing that we will need to do in this coroutine is yield some time. So yield wait some time. So let's create var random time equals, we are going to call random dot range, and we are going to pass here our min delay and max delay. Okay, and we have this issue with the random because we are everywhere using this Unity engine.random. So let's delete it, and instead let's Alt Enter on random, and let's choose this using random equals Unity engine.random. Now all the random will be pointing to our Unity engine.random. Okay, we have calculated our random time to wait. So what we can do is type in our coroutine yield return, and we are going to call new wait for seconds, and we are going to pass our random time. And this will be it for our coroutine. Now we will need to move to our spawn enemy method, which will simply call instantiate. We are going to pass here our enemy prefab. We are going to pass here our spawn position, or we have a spawn point, and we are going to pass here quaternion dot identity as the rotation. Great. We will need to make sure that we start our coroutine somewhere. So let's type start. Okay, we are going to create this method, and in the start we are going to first check if our maybe spawn points dot count is greater than 0. If it is, we are going to be able to start spawning enemies. But first of all, what we would like to do is spawn enemies in each location, so that at the start all spawn points are filled with enemies. So we are going to type for each tab var maybe spawn point in spawn points, and for each of those points we are going to call our spawn enemy, and we are going to pass our spawn point dot transform dot position. So we are going to spawn enemies in all the spawn points that we create, and then we are going to call start coroutine, and we are going to pass our spawn coroutine. Okay, and this should be it for our spawner. So let's go back to Unity. We can see that some fields are giving us errors, so let's double tap on one of those warnings, and let's set the values to be null by default, so that it doesn't throw us an error, or rather warning. Let's save it, let's go back to Unity. Now the warnings should be gone, and what we can do is drag our enemy spawner here, and as the enemy prefab, of course, we can go to our project section prefabs and drag our enemy chart, but we will need to create some points for our spawn points. So what we can do is right click on the enemy spawner, add an empty game object, and in the inspector we can choose this square, and let's select an icon for it. Okay, I do not see the gizmos because I have in my scene gizmos turned off. I'm going to turn them on, and we can see our new point. Now I'm going to place those points in the corners of our room. Actually, let's rename it first to spawn point. Okay, And I'm going to Ctrl D in the hierarchy on the spawn point and drag it in the scene view using the move tool to the corners of this room again. And make sure that you do not go too close to the wall, because our enemies will spawn inside the collider, for example. So we might want to fix those when we have an issue with this, because otherwise our enemies might be stuck in the collider when they are spawned. Okay, and what we can do is we can add those to our spawn points list in the enemy spawner. So let's drag spawn points that we have created to our list, and we should be good to go. Okay, the default setup is pretty good, so let's now press play. And we can see our enemies are appearing continuously around those spawn points. But unfortunately, they are not attacking our enemy because we are too far away from them, because their setup for the chase state is too low, so the detection circle is too low. So let's stop the game and let's drag one of our enemy charts into our scene view, and let's open it up. And in the AI section, we're going to choose idle state, and we have this transition chase with the AI transition with the distance decision. And we have forgotten to implement the view decision, so if there is no obstacle, we are going to do this in the next video. For this, we will need to increase the distance radius, and we can see that this is a pretty good distance. So we are going to set it here, and in the chase state, back to idle, let's increase the distance as well. So those now will be the distances for our enemy. And we can see that it doesn't reach our player. So what we may want to do is we may want to edit this distance decision to increase the distance range. So let's click on those three dots, edit the script, and at the top, let's increase the range to 15, for example. Let's save it. Let's go back to Unity. Okay, my script has recompiled. So now I can increase the distance to something like 12. And for the transition chase, let's do the same, about 12. Now, let's select our enemy chart in the hierarchy, overrides, and let's apply all. Now we can delete our enemy chart, and when we spawn our charts, they will start attacking us. And we can now experience some kind of gameplay in our game. So in the next video, we are going to make sure that we fix the issue with our enemy so it can detect the line of sight. And we are going to also start implementing a way for our enemies to drop packages on the ground. And now you might want to play with the enemy spawner. Let's set, for example, the count to something like 50. Let's set minimum time to 0.5 and maximum time to 1. And let's see if this makes a difference. You can see that the enemies are appearing much faster. And this gives us this impression that there is a horde of enemies that will attack us. Of course, you can play around with their health, but basically that's what we have achieved in this video. Okay, see you in the next video. In the previous video, we have finally finished implementing our spawner so that our enemies are constantly attacking us. Now, one thing that I have forgotten to implement is the line of sight for the enemy, so let's quickly fix it by implementing another decision to our AI. So let's go to our AI, to the decisions, and let's implement a new C# script. So right click, create a C# script. Let's call it look decision. And let's open this script up in Visual Studio. Great. What we will want to do is let's delete update and start. And instead of mono behavior, let's extend AI decision. It will want us to implement an abstract class. So alt-enter abstract method. So alt-enter and implement abstract method make a decision. Great. Now what we are going to do, we will need to have a private float, and this will be the distance. Since we want to shoot a raycast, and we always want to set a distance, so let's set it to be 5 by default. Let's add to it serialized field, and maybe let's add to it a range attribute from, of course, we can set it from 0 or from 1 to 15, as we have the 15 as the farthest distance for detection. And maybe let's set the distance to 15 as well. So the default distance for the look decision is the farthest that we can see. Great. Now what we will want to do as well is we are going to have a layer mask. So let's create private layer mask. Let's call it raycast mask. And this will be the mask that we'll use to raycast, so we will be able to ignore some objects and only detect objects of type obstacle and player. Let's set it to be a new layer mask. Since this is a struct, we cannot set it to null. Let's add to it serialized field as well. What we will need to have as well is a prop tab, and we will have a Unity event, because as I recall we have implemented a way for the enemy to grunt when it sees our player, but I don't think that we have implemented it. So let's type public Unity event, hold enter on it, and we will be using Unity events, and let's name it on player spotted. Okay, great. And again, we will need to add to it an attribute. So let's add a field colon serialized field. Great. Let's slide down to our make a decision method. Let's, instead of throwing an exception, calculate direction. So var direction equals, and we are going to type enemy brain since we have our access to our enemy brain. Okay. Dot target, since this is the target, so the player, dot transform dot position minus transform dot position, so the position of our enemy. Next, what we will want to do is to create a raycast hit. So let's type raycast hit 2D hit equals physics 2D dot raycast, and we are going to shoot a raycast from our transform dot position, so from the enemy, towards the direction that we have calculated. Okay, and we are going to pass to it distance as the distance for the ray, and raycast mask, so that we only detect the specific objects and not, for example, hit our own collider. Next, what we are going to do is we are going to call if our hit, so the result of the raycast dot collider, is not equal to null. If this is so, we are going to call on player spotted question mark if anybody is listening to it dot invoke. Okay, and we are going to return true, so we can transition to the chase state, else we are going to return false. Okay, and let's create onDrawGizmos method so we can show how our look decision works. So let's type onDrawGizmos, space enter, so that we can create it from the snippet, and we are going to check if our Unity engine, Unity editor dot selection dot active object equals game object. So if this is the active object and enemy brain is not null, and we are going to also check if our enemy brain dot target is not null. And only then we are going to be able to call our gizmos. Let's change the color of the gizmos to be color dot red, and we are going to call our gizmos dot draw array, and we are going to draw array this same as we did previously. So let's copy the direction calculation from the make a decision. We are going to paste it here below, or we could set it as the field here in the look decision. So we have calculated the direction. We are going to draw the ray from our transform dot position, and the direction will be the direction of drawing the ray, and we are going to call dot normalize on it, and we are going to multiply it by the distance so that it shows how far our raycast is being shot. Okay, let's finish this statement. And actually, to detect if our collider is not an obstacle, we will need to add another line in this if statement. So let's type and if hit.collider is not null, we are going to simply check hit.collider.gameObject.layer, and we want to check if this is equal to our layer mask. So this is the way that we can access our mask name, or mask index rather. And we are going to call name to layer, and we are going to type player with capital P, because I think this is the name of our layer for the player. So only if we hit the collider of type player, we are going to say that we have spotted the player. if we have hit the obstacle, we are going to say that we have returned false from it, and we are not going to detect the enemy, for example, so we are going to avoid hitting our enemy object. So let's save it. Let's go back to Unity. Okay, what we want to do is go to our prefabs folder and drag one of the enemies into our scene. And now what we want to do is open it up in hierarchy, choose the AI, open it up, and we are going to only add the look decision to the idle state. So when we are already chasing the player, our enemy will still chase the player until it goes out of the range of the distance detection. But for the idle state, we are going to require the enemy to actually see the player, so the player is not around the obstacle. So what we are going to do is we are going to make sure that we choose our transition chase, and we are going to add here a look decision. Great. The distance is set to 15. Let's set it to 12 as is the distance decision. And what we can do is we can set in the raycast mask, we can choose the layers that we want to raycast against. So we want to ignore all the layers but the player, and click on it again, and you can select another one, which will be the obstacle. And now we also need to add this to our decision. So let's add our look decision to our AI transition. And this will be the second decision. After we detect the distance decision, we also want to detect the look decision. Let's for now disable our enemy spawner. And if we press play, it will not work. And why is that? Let's click on our AI. Let's choose our idle state transition chase. And the raycast is indeed being shot, but it is not hitting our player. And this is because if we click on our player has no circle collider around it to indicate that we can hit it. So instead we are going to choose the player. We are going to add here a circle collider to D. Okay. And what we will want to do is we want to make the circle collider a trigger, and let's make this radius pretty big so our enemy can hit with the raycast our player. So now if we press play, our enemy will see our player. So let's choose our enemy chart, overrides, and apply all overrides. Let's delete it. Or actually, let's wait. Let's Ctrl Z to undelete it. And let's create a new game object in our scene. So let's right click, create an empty game object. You should see it in the scene, so let's drag it between our player and enemy. Let's set its Z position to 0, so the raycast will detect it as a collider. And let's add to it a box collider 2D. Great. And let's set its layer to be that obstacle. Now if we press play, our enemy is shooting the raycast, so let's choose our enemy chart, AI transition chase, and it is shooting our raycast. It is hitting our new game object that is an obstacle. If we move it, it starts attacking our player. So it all looks like it works great. So let's delete our game object, delete our enemy chart, and let's re-enable our enemy spawner. And I have almost forgotten to implement the enemy grunt. So let's choose our prefab, let's drag our enemy chart onto our map, and we have implemented to it the new decision, so AI idle state, and we have our decision transition chase. Our decision is look decision, and we have created this on player spotted. So let's click plus icon to add an event, and what we are going to do is we are going to drag here our agent sounds, and we are going to choose function agent sounds, and we should have player voice sound. Okay, I have misspelled it, doesn't matter right now. We will play this play voice sound when our enemy spots our player. So let's choose our enemy chart, overrides, let's apply all, let's disable the enemy spawner, and let's make sure that our enemy chart is somewhere farther away. What we can check is the distance. Okay, let's move our player outside of the distance of our enemy. Let's press play. And when we go closer to our enemy, I'm going to disable the background music. I'm going to go closer to the enemy. And you can hear the sound. I don't think we have the proper sound for it. So maybe we want to play around with the sound that we have for our chart, for our agent sound, and for our voice clip. So let's choose those. Okay, I think this Ogre 1 it should be better, so let's choose our agent sounds and drag Ogre 1 instead of the voice clip Ogre 2. And now let's choose our enemy chart, overrides, and apply all. And now again, let's press play. I'm going to disable the background music so that we can hear. And we can hear that the enemy now has discovered us, so this is great. And that's it for this section. In the next section, we are going to make our enemies drop ammo and health packages, so see you in the next section.